Okay, I think my audio should be good now. So let's go ahead and get started here. So it has been a little bit since we've looked at multiplayer stuff. So let's get started with some questions folks have had on the Discord about getting started with Steamworks and Steam multiplayer. So Netcode for Game Objects has support for custom transports. This is kind of the low-level interface for your networking stack. By default, Unity has their own transport layer, but there are transports for other services like Mirror has one, Photon, I think, had one, and there's a couple for Steamworks for Steam P2P. You could technically write one for Epic Online Services as well. I haven't seen one of those in a while, but I'm sure they're out there on the internet somewhere. But we are going to focus in this first part on Facepunch Steamworks, which is from the developers of Rust. They made a Steamworks wrapper since Valve's Steamworks is C++. So they needed a wrapper to make that work with C# and Unity. There's also Steamworks.net is another one that you can use. There is a transport out there for it, but I decided to go with the Facepunch transport. To actually get this transport, you need to grab it from the GitHub. So there is a multiplayer community contributions repo that Unity supplies. I'm not sure they actually maintain this for various community contributed components. These are pretty old, actually. A lot of these have not been updated in years, but they don't really have to be. These are the various transports we have. Some of these just aren't even applicable much anymore, like the WebSocket. That's built into Netcode for Game Objects now, so that's not a thing. But here's the Netcode, the Steamworks.net, and the one for Facepunch is here as well. There's a couple other components here, like network discovery, network pool and stuff. Yeah, they are somewhat outdated. But the Facepunch transport, it's a couple years old, 4, I guess. Got updated last year. Not a whole lot actually has to change on these, so you're fine using them. I think the last thing this updated was some issues around disconnecting. But all you really need is this Facepunch transport class here, and also the actual Facepunch here. So this is the actual Facepunch library. You don't actually need this. This one is super out of date. You can still get Facepunch Steamworks itself from their GitHub. Theirs is maintained reasonably up to date, so they try to keep up with Valve's updates as well. So you're not going to be too out of date here, even though some of these files are kind of old, but it's fine. To actually install Facepunch Steamworks here, once you grab it from the releases here, this is 2.4.1. What you'll do is there is a Unity folder that you'll need to copy over into your project. You don't have to do anything else with it. just copy that Unity folder into a plugins folder in your assets, and that's really it. So here I grabbed plugins here. So in the zip folder, you'll have a Unity folder that has all of the DLL files in it. And then I just grabbed that Facepunch transport here and dragged it in this folder. Doesn't really matter where you have this file, but I like to keep it all together. So after you have all of that in your projects folder, back in your network manager, this is just an empty game object with a network manager on it. When you first install it here, this network transport will be blank. And then you have this drop down menu here that says select transport. And here you'll see the network transport, Unity transport. There's one for distributed authority. We went over that earlier this year. There's also a new single player transport. So if you are creating a game that can be single player or multiplayer, you can just have a single player transport and not have to worry about connecting to yourself as a host. You don't have to split your code base up. But anyways, we're dealing with Facepunch transport here. When you select that, it will add that component here, and it will add this Steam ID and then your target Steam ID. So your Steam app ID is going to be the app ID that you get from Steam when you sign up for a developer account. I believe it's still $100 to get a developer account. And when you create your Steam page and all of that, they give you an app ID. And that app ID is going to be what every client is going to end up connecting to. So there is a default kind of demo ID, which is of 480. This is a game called Space War, I believe. That's kind of just a demo that you can connect to like while you're developing and stuff. So this is what we're going to use to connect as an app ID, because I don't have one of my own just yet. And the target Steam ID, this will be the player ID of your host that you're going to be connecting to. That's kind of it to get started there. In order to get the Steam ID that you're going to be connecting to, that's basically going to be the server or the host. And to get that, we are going to use lobbies here. And this is just a really, really quick and dirty script here that will display your Steam lobbies and display a little join button that we can use to set the target Steam ID that we need to connect. And here's our code here. This is using UI Toolkit instead of the UGUI. So it might be unfamiliar to some people, but it's real easy to do. It's mostly code-based, actually. But it is not very pretty to look at, unfortunately. But it's easy enough to do the style sheets to get everything the way you actually want it. But again, this is super quick and dirty. So I also have some Unity services that I was kind of messing around with. I didn't quite get the friends, Unity friends started up here. This is Visual Studio Community. I do have Visual Studio Code, but it kept breaking the IntelliSense, so I just switched back to Visual Studio. It's fine. A lot of people swear by Writer as well. It's whatever floats your boat. So Steam matchmaking is going to be the singleton class that a lot of the lobby services will end up using. This has a couple of events that we can subscribe to. So when a member leaves and when a member joins, we're just subscribing to this and start. Here we grab our UI document component. This is where the UI toolkit elements will be displayed. And we just grab its root because that's where we're going to be adding our buttons and lists and all that. And the first thing we'll actually do in start is that we will grab all of our lobbies that we can find. We'll go over the connection approval stuff here in a second. This is basically the only way you can prevent users from joining your lobby that's out there. If it's public, people can just join it. The Steamworks is kind of weird in that there's not a way to actually kick a player after they've joined. So if you like have been banned for whatever reason, it's really kind of hard to prevent that user from coming back. Okay. So here in, I guess we'll start with the setup lobby view. So in our root object here in our lobby source, you can double click on it. This will open up the UI builder here. And this UI builder, we went over kind of this a while back, but this is kind of a, I would say like almost a web dev kind of workflow for creating UI. You have this UXML document, which is very similar to HTML. You have a USS Unity style sheets, which is a subset of custom style sheets. And here we have a panel for our lobby, where our lobby list is going to live. We have a scroll view here where our content is going to end up being. And then we have our names. So we'll have a panel, we'll have a list view, add content into the scroll view. I'm not doing anything really fancy here. I don't think I have any style set up at all. So it's all just default stuff. And you'll see in a second here when I hit. So back in the code. Here we do the root, which is where our document we got. This .q is a query. So we're going to query our document for any list views. The first one it finds with the name lobby list view, we're just going to grab that. And then here, if we find a list view, then we will assign its make item, find item, the item source. This is where it's going to get its information from, and the fixed height here. Here in make item here, this is where we are going to create the lobby item. So this is just going to create a row that has a name, and we create its style with a flex of grow. So it's going to fill our panel, and we flex direction row. So it's going to be horizontally left to right. It's going to fill the entire panel. And then we add it to our container. It's just going to be a new element here. So this is the name label. It's just a text. The same thing here. We're doing a player count. And it is just going to grab the number of players that's in the lobby, add that to our lobby item, and finally just a join button here. The next thing here is the find lobby item, this is basically assigning all of the data to these elements that we just created. So here we have our lobby data, which is going to be just basically a list of our lobbies. So for each new item, lobby that gets created, it's going to have the element for it and its index. And then we set our name to be the label name. We have lobby data with its name. We grab the player count, which we're grabbing the player count and the max players. So we'll have a 3 out of 10 for the max players. And finally, for our button here, this is assigning the event when it's clicked, what is actually going to happen here. And it's just going to fire off this on clicked event. Okay. So actually fetching our lobbies. Actually, I guess we should go over creating the said lobby. So when we create a lobby, all we have to do is create, we just call Steam Matchmaking .create lobbies async, and this will give it the max number of players. Default is 100 players. You can have it whatever you want. For Unity lobbies, I believe the limit is 150 players. So now, since we are using the 480 app ID for Space War, there's going to be literally hundreds of thousands of lobbies because everybody and their grandma is using that for dicking around with Steamworks. So we can't just get a list of lobbies and then try to find ours. So we have to limit it in some way. And to do that, you don't have too many options. So you can query by data or by whether it's public or not, and if it's actually still joinable. So when we create a new lobby, we are just going to set its data to whatever. It doesn't really matter. It's just a key value pair. And I just made the key and the value both MGD. So when we query our lobbies here, we just have a new lobby query, and then there's some settings we can set here. So we have with available slots. So this is with a specific number of slots available, so at least one. We have with key value, so that's the data that we just set. And then we have the max results, which will be 10. So it's going to be like, if you wanted to do like pagination or something for multiples, you can just have, 10 at a time. And then once we have all that set up, we just call the request async, and then this will eventually return our lobbies. Once we have this, we have a little another function. This will roll through our lobby list and then just update everything. So here we are adding to a list of lobby data. This is what the UI toolkit will be pulling from. And then this is a struct I just made that is at the bottom. Our actual lobby data is just going to be the name, the player count, the max players. Technically, you could set other things in here like game type, map data, or whatever you wanted here. So you could technically search for like deathmatch or capture the flag or whatever. Okay, and then the lobby data will also have a action that we are setting to join lobby. So when you click on the join lobby button, this will fire off and it will try to join said lobby. Then at the bottom here, once we have all of our lobbies returned, you have to call the lobby list view.rebuild, and then this will refresh all of the actual graphics, the visuals of the UI document. And to actually join a lobby, you only need to just call your lobby that we are joining, and then just call .join, and you just join that lobby. A lot of this part here is part of the connection data. So what we're doing here is we are getting the Steam user session ticket, and then we are going to send this to the lobby owner. The lobby owner is going to validate this ticket and then accept it or deny it. So if your Steam account has been like VAC banned or whatever, it will deny the authorization request. And we send this over to the host with connection data. And this is through the connection approval process for Netcode for game objects. You could send this as like a lobby chat message if you wanted to, but this is, I guess, cleaner. So here we are grabbing our connection data, which is going to be our ID and then the ticket data, saving that to JSON, turning the JSON to a byte array, and then saving that into our network config connection data. This will get sent to the host automatically whenever you connect. And then here I'm setting the Facepunch transport target Steam ID, and here we finally get to our lobby.owner.id. This will be the host that we're connecting to. Once we have that set, that's all you need to actually start your client and then actually connect. And yeah, so here's the approval check. So whenever somebody connects to the host, it's going to go through this approval check here. We decode the JSON that we just sent. We turn it back into connection data. We, on the server here, or the host, we call begin auth session. We give it the ticket, the data, and that client ID of the connecting user. And then we will either get a auth OK, in which case we are approved, or it is not. And then if it's not okay, it failed for whatever reason, we send this message back to the client and let them know what happened there. Then once everything either is approved or not, actually this probably should return. I guess it's fine. Here we set our create player object to be true, so it will automatically create a player object if we have that set up. And then once we set pending to false, everything goes through. So this has an actual timeout of like 30 seconds or whatever. And it's fine for this. I don't think this actually takes long at all. But if you're doing other checks, maybe you have another database that you're checking for banned lists or whatever, that could end up timing out if things take too long. Okay. I think that's it for that. We can show how that works, maybe. So the thing with Steam is that you can only be on one Steam account per computer. So it makes it kind of tough to actually test these. So normally what you would do is you would use something like multiplayer play mode to spin up some virtual players on your computer in order to have them connect to each other. But with Steam, you can't do that. because you can only be on one Steam account and accounts can't connect to themselves. So what you need to do is have a separate computer somewhere to actually test this out. And I happen to have my laptop over here, so we are going to try to connect here. So once I hit play, we're going to see screen pop up, some buttons. Maybe if I break everything. There we go. So when we first connect, you should be able to see that fine. We have a create lobby button and then a refresh lobby list. And I guess right now I could actually join. So if I create a lobby here, normally you would disable this once you actually connected. But if I refresh the lobby list, we have our name, our number of players, and then our join button. So here is me. Okay, so here on my laptop, I'm going to click join, and then you should see another player pop up. Maybe. Yay! So anyways, that works. That's cool. And then when we refresh the lobby, we'll have our 2 players here. That's really it. I don't have the friends list or Steam chat set up yet, but the connection part was kind of the tricky thing here. All right. I guess I ought to have a leave button. Okay. I'm not sure what that's about. Oh, I think these was null or whatever. But anyways, so yeah, that's gonna be it for the Steam lobbies. I might try to do like Steam friends list and invites and all that stuff. Maybe later down the line. The Steam lobbies are kind of jank. I actually prefer using the Unity lobbies, but some people like using the Steam P2P, which is free, so you don't have to worry about the free tier of Unity Relay, which if it, your game blows up and goes viral or something, you might get hit with some fees, but that's a good problem to have. You should be monetizing your games anyways. Okay, so let's back out of all of this, disable this manager. We're going to go back to Unity Transport, and way easier is the multiplayer widgets. So this is from the package manager, multiplayer services and multiplayer widgets here. These you can get from the window multiplayer center. This is a real cool wizard for configuring and installing a lot of your netcode options here. So if you wanted to make whatever type of game, adventure game with 16 players that might be fast-paced, maybe not so much cheating, cost as little as possible, client server. Basically, for anything fast-paced, they're going to recommend Netcode for Entities. If it's a slower-paced co-op thing, Netcode for Game Objects is fine. So here you have the different options that it'll recommend to you. You have your multiplayer widgets. So the widgets are pre-built UI doodads that will make connecting, viewing, navigating around sessions just a lot easier. And basically what this gives you is a number of widgets here for creating a session. You can join a session by code, session list, quick join session, some info here for session player list. Wanted to see how many players there were. And then you can have the session code pop up on the screen. It also has chat built in as well. So if you're using voice chat for Vivox, you can select your input and output devices, or you have a little text chat window. I really just like using the quick join and leave buttons here, and that's what these are. And when you create one of these buttons, you will also get a default widget configuration scriptable object here. And this is just a quick quick start kind of configurations here. It will have a name of a session, the type. You can make it relay, direct connect if you're like connecting to a dedicated server or whatever, or distributed authority. I'll keep it on relay here. We have our max sessions. If you want to enable voice chat or not, this will do all that automatically for you. And all of this will initialize, set up, and start all of your services and stuff for you. Here on our quick start button here, we just have a quick join session component here with some events that you can subscribe to. So if you wanted to switch scenes or whatever you wanted to do, you can do that when you join a session, or pop up error messages when you fail to join. For quick join itself, if it doesn't find any sessions, it will automatically create one if you select it down here. And this, we can actually use multiplayer play mode. For this, say here, this will spin up a new editor or a stripped down editor that we can then connect to. Okay, so here's our little editor window here. It's kind of stripped down. We don't have the hierarchy or the inspector or even the scene view here. We can open up the profiler, but I usually have this up on a separate monitor here, and then I can just hit play. When you hit play at the top, it plays on the other clone as well. Here. So here it says we are initialized, we are signed in, get our player name automatically and an ID. Then we can join. We can see in the console here, we joined a session. We're in a chat channel, and it is the exact same. So I can walk around here. You can join. We join automatically with a. It doesn't tell us our name here, but I can walk around here too. Oh, I wanted to talk about this. So these characters, these are the standard assets from Unity. This is from the starter assets character controllers. This is supplied by Unity. It gets updated pretty frequently, but it has first-person controllers and third-person controllers. But these are not really set up for multiplayer. but it is actually not all that hard to adapt it. Usually adapting something from single player to multiplayer is a huge pain and definitely not recommended. But it's my third person controller. Here, the starter assets. Nope, I saved them. Okay. So this is basically identical to the third person controller that came with the starter assets. Down. The only thing I changed here was I made the mono behavior into a network behavior. And then I added some other controls to basically check whether you are your local player or not, since this is going to be client authority here. What do I do with it? So I named this to be network behavior. And then further down here, we changed start to on network spawn. There is some weirdness with how awake, start, and spawning works. The timing gets a little weird. So anything that is normally happening in start or network stuff, you want it to happen in on network spawn. The controller is using Cinema Machine for the camera. So that is a bit tricky since this is a scene view, and the Cinema Machine camera is going to be in the scene already. It is not going to be networked here. So we have our main camera here, which has a Cinema Machine brain. We have the player follow camera, which is going to be the virtual camera here. So right now in this scene, there is no player. So it's not actually following anything here. This tracking target is going to be blank. So we need to assign this when a player spawns in. But we only want to assign this for our local player. If a second player joins in, we don't want to assign that player to this camera that we're controlling. So here in on network spawn, we are going to grab a reference to our Cinema Machine camera. So we're just going to get camera.main get component. We get the Cinema Machine brain, and then we grab the active virtual camera. So that's just going to be this player follow camera here. The other thing you need to keep in mind is that our player controller and our inputs need to be disabled for non-local players. So we only want our player to have a controller. We only want our player to have inputs. And same for our player input. So if we're not the local player, when this spawns in, it's just going to disable it all. Because is local player is going to be null here, or it's going to be false. The same for the skinned mesh renderer. For our local player, I am just disabling it. You could technically have your, you can keep that enabled if you wanted to see your player arms or whatever. You could do that. It looks really weird when you do it that way. So a lot of times you'll have special like first person arms that will get displayed while you're in first person. But because I'm using the same object for our first person player and the remote players as well when they spawn in, I'm just disabling the skin renderer on our player just so we don't see the camera clipping through our own self. This, we will go over there is a new kind of attachment system that we're going to be using for picking up items in the world. There's a lot of actual rules and stuff when it comes to parenting network objects to each other. That makes it kind of complicated. And in this last update of Netcode for game objects, they created a attachment system that we'll go over here that makes just attaching objects to each other really simple. So here, continuing on here, so if we are the local player, then we are going to set the camera.follow to be our sim machine camera target transform. And that is in our player prefabs. So in our player here, this is just a standard third person asset here. We have the armature. This is what I put the controller on. We have a network transform here. We set it to owner authority since our player is going to be controlling themselves. That's really all I changed there. We have an owner network animator. So for the animations to sync up, when you change your animation state, that gets sent out over the network and will make sure everything is playing at the right time. We also have a rigid body and a network rigid body. This is actually kind of important here. This is newer in Netcode for Game Objects 2.0. There is a auto update kinematic state. So by default, rigid bodies get set as kinematic on non-local players, and on the server or the host, they'll be set to kinematic. So normally you would want all of your physics to be controlled on the server because it's non-deterministic and syncing physics is hard. So normally you just want the host to be controlling all of your physics, but that creates all kinds of lag and stuff. So for client-controlled stuff, you'll want to leave the hosts to leave the clients to be controlling their own rigid bodies. So this auto update will keep the kinematic states to be whatever you set it as. So for the players, they're going to be non-kinematic since they'll be walking around. But in our player here, we have a camera root object. This object here is just going to be what the cinema machine is going to be following. You might be tempted to make the cinema machine to target just the player or the root, but as you can see here, that is down by the feet. So that will get weird if the camera is tracking too closely to the player's feet, unless you got like a top-down game or something like that. But here we can just set it this shoulder height. If you wanted to, you could raise that up to eye level. It's kind of what we're doing here with the first person view, but it's not that big of a deal. Okay, so we have it setting up following that camera target. For the local player, we are setting the camera distance to 0. That's just because I wanted to see it as a first person kind of view. And then this is the transform item holder. I'm not gonna go over that just yet. And that is basically it. For the update, I just have it to, when it's not the local player, to just bail out early. So you're not gonna have any of this happening for the remote players. This will only be running for the local players. Same for the late update. Everything else is standard. I didn't change anything else here. All of this stuff will just run for the local player. The network transform will keep the player position in sync, and the network transform or the network animator will keep the animations in sync. Okay. And I did the same thing for the first person player controller as well. It does the same thing, but if you wanted to just have a strictly first person player game, you could do that too. All right, so let's talk about this attachment system. So here, I've got weapons kind of strewn about the world. And this moving platform moving back and forth. Moving platforms is actually really hard to do over the network. It's really hard to do in general, really. And the basic way to handle moving platforms is to parent your player to the moving platform so it sticks to the platform no matter how it's moving. Over the network, this will end up creating some lag, but it's actually not that bad with this players. What do I have? Not here. Here, I have a player attach behavior. Here, this is attach behavior on our platform. Here, we have a node behavior somewhere, our attachable node. So this has a network transform and a network rigid body just to keep things up in sync while it's moving. And here, when we collide with the platform, we're going to parent ourselves to it, and then we move back and forth here. And I can move on the platform. I can jump here, and I stay parented to the platform. When I get off of the platform here, I unparent myself, and I am back where I was. You can also see I can pick up these weapons, and they will automatically attach themselves to my camera. No, I attach it to the root here. So here, when something gets attached, it gets parented to the actual node object here. And then I have it set up so I am switching out the material. I don't think the actual object is when I mouse up or down. I probably want to do some kind of animation or something when I switch, but right now, I just wanted to make sure this would actually work, which is really cool. So as I mouse down, it scrolls through each of those. And when I join to the other player here, I haven't quite figured out how to deal with that lag. And also, you'll see it's got the wrong item here until I switch. Then it fixes itself. I'm not sure what's up with that. It's probably something with how I've got the network variables working. But here, when I pick them up, boop, boop, boop. And here. See, and since it's attached to the hand, the animation syncs with the player. And since I have it for the local player attached to the actual camera, you're not going to see it move around on the player side like you do on the boat side. You might want it that way. I don't know. I liked it better with the static weapon in the first person view. So how this works is in our attachable node, what we do here is this is going to be on the player, and this is basically going to be like your player inventory. So I'm going to have a network variable of the currently equipped item, and this is going to be the equipable item class that I have here. This will be on the actual object. So here I have an event here for when the currently equipped item changes. This will get fired off, and then we here will stop any particle effects that are on it, and we disable the renderer for it. Here, since it's a network behavior reference, we have to convert it into an attachable behavior, and then we end up getting the mesh renderer enabling any particle effects on it. There's an event that happens when it actually attaches to the player. For this, we are just going to call the equipment change. In our update, this is how I'm handling the scrolling and dropping items. So when you hit the tab key, you're going to drop the item. For the switch item, all we're doing is changing the equipped network object or network variable to whatever our current inventory is. So the inventory up here is just going to be the list of attached behaviors. So whenever something gets attached, it's going to get added to this attached behaviors list here. And we just cycle through all of the attached behaviors. And then once we change this, this will get synced out to all the clients, and then it changes what is shown through the renderer. This is the equipable item. There is also an item pickup script. Oh, no. Item pickup. Okay. So the other thing is we have a component controller. This is also part of the here. All right, so here is the component controller. So this can control what components are active or inactive when it is enabled. So basically this is used for when something is picked up, certain components will be disabled. When it is dropped, it will disable and re-enable said components. So basically what this does is here we have this sword that is like in the ground. There is a whole bunch of particles and stuff while it is in this state. We also have another game object that is the sword in the hand. And this one is just the sword without any of the particles and stuff on it. that is going to be disabled here. The component controller is going to be what controls when things are disabled or enabled. So we have the sword in the ground, the sword mesh, all the different particle systems, the glow particles, distortion, all of that stuff is going to be enabled when this is enabled. We have the sword in hand is going to be inverted. So it's when this is enabled, this will be disabled. The equipable item here, this will tell the component controller how to actually enable on attach or not. So when this is going to be attached, the controller will be disabled and everything kind of goes away from the stuff that's on the ground. Now, one of the gotchas for this is that when an item gets detached, it will reparent itself back to its original parent. And normally, the parent wouldn't actually move. So when you go in here and pick up, say, this sword, if you were to detach it without moving the parent at all, it will, let's see, because you can see this is the fire sword in the ground. Here its renderer is disabled and stuff. But when you were to detach it, I hit tab, the sword in hand goes back to where it was. So you have to actually move the parent to where you want it to be when you drop the item. Otherwise, it would just teleport back to where it originally was. Again, you might want that behavior. So for like a first-person shooter like Halo, where your weapon spawns are in specific locations. So if you were to drop a weapon and then when it later respawns, you might want it to respawn back at its own spawn point. I wanted it to drop wherever you were. So we just have the behavior here on attach of the equivalent item. We are moving the default parent to its position. And when we detach here, we are just, when we drop the item, we're just moving the item's parent transform to be slightly ahead and to the right of the player. You could like apply some forces if you wanted to just like throw the item if it had some rigid body physics on it. I didn't feel like doing all that, so we're just plopping it down. I probably should adjust the Y value though, because I think it is kind of hovering above the ground because of colliders. Whatever. And we do the same thing here with this platform on our player. We have here. This is the player attach behavior. And basically we're just using a collider to, when we collide, we're going to check if it is an attachable node. And then if it is, and we're not already attached to it, we will attach ourselves. And you just call attach to the node you want to attach to. And then at that point, you're going to be parented to that. But when you parent, it's not going to change your local position. So you're going to be kind of stuck to it as your relative position. So you need to change your local position to be 0. You'll want your local rotation to be the same rotation. Otherwise, you'll snap like looking straight ahead or something. So you save your previous rotation. You'll attach yourself, reset your local position to be the position of whatever you're attached to, and then you want to save yourself the original rotation. So you do all that, and then you will you won't notice any weird jumping or hitching when you reparent yourself. And then the same for our detaching. Basically, if you collide with anything else besides this platform, it'll detach the player. And then once you detach, you will go back to your original parent, which we are moving with ourselves. All right. The other big thing that I was working on is kind of a mech combining game. And what I've got is basically players will attach to each other, kind of Voltron style. And for this, here's my mech. For this, it's just a cube. And when you attach to another player, you're going to become the turret for that player. So basically, the tank body will be controlling the movement, and the other player will be controlling the actual turret. This is still using the starter asset inputs here and the tank controller. This is also using the anticipated network transform. I'm not going to go too deep into that, but it's basically a way of like reducing lag because everything will be, it's kind of a pseudo client prediction system, but it's a bit much to go into right now. And it doesn't really work with rigid bodies. It's a pain. But this is just a super simple tank controller with back, forward, left, right. And when we press the E key somewhere, match tank. Oh, it's in the mech control. Here we go. Here in our mech behavior, when we press the E key, we're just going to do a physics overlap sphere. It'll get anything within range. And the first player it encounters, it will attach itself to the player. And then on attach here, on attach, it's going to change its local position to be just above the player, and then it changes its scale to be more gun-shaped. And then we turn off the mech body, which is just the tank controller, just so we don't accidentally attach to ourselves. And then when we detach, we just do everything else in reverse. So we will plop ourselves down, kind of ahead of and a bit to the right to where we were. And then we reset our scale back to 1. Eventually I'll get like proper tank graphics and stuff. But this is going to be sending an RPC, which is just RPC to the server to attach and detach ourselves. Oh, yeah, that was another thing. Uh, you had to have authority over the node in order to attach to it. So this has to be a server RPC to the server, um, since the server is going to have authority here. So let's check this out. We join, we have a, oh, that's what I'm going to change. Shoulder offset should be, okay. This will just put the follow camera a little bit higher. Okay. A little bit. All right, so we can move around a little bit here. Good. Then here we can move, and then when I hit E, so now I can move around. Other player can control turret. Pretty cool. Here we can still move around, and got physics kind of working. Oh God, I forgot to lock. I forgot to lock the physics. But anyways, I'll go upstairs. I think, and then I can, crap. This is what happens when you try to combine with yourself. That's back. Oh no. Oh well. Fortunately, once the client leaves, or the host leaves, everything else goes away. But yeah, that's what I've gotten so far. Eventually I need to make it so multiple players can connect to each other. Right now it's just the one player can connect to another player. And I might have it so you can do it by site. So you would select which part to join. So whether you want to do the left hand or right hand, or the legs or the head or whatever. And that would also be separate attached nodes to connect to. And also, the second player is a bit stuttery, and I'm not quite sure why that's happening. It's good on the host, but when you move, it's kind of weird. Yeah, to show both of those at the same time. Why? Okay. So yeah, I think that is about it. Yeah, I'm not sure what we're going to talk about next month, but tomorrow we are going to be having a meet and greet over at Dave and Buster's for National Video Game Day. This will be the first time that we have met up in person in quite a while since Global Game Jam. So hopefully we will see a bunch of people there. It'll be at 6 p.m. at Dave and Buster's over by Wolf Chase. And yeah, hopefully we have a pretty good turnout. And I guess we will see you guys there. If you guys have any questions or comments or whatever, feel free, join up in our Discord. Links there in the video, or drop a comment on the YouTubes, and we will talk with you guys next time.